Hey everybody, welcome to Geometry. We are about to have our first lesson in Module 2.1. Let's do it. So our lesson is about conditional statements. So a conditional statement is a two-part logical statement. The first part, well, not necessarily the first part, but one part is the hypothesis. And we use the letter P to represent our hypothesis. And then we have a conclusion. And we let the letter Q represent our conclusion. We can write them in an if-then form, like if P then Q. The if part has our hypothesis and the then part has our conclusion. They're not always written in if-then form, and sometimes we have to decode the statement to figure out which part is the hypothesis, which part is the conclusion, so that we can think about them in if-then form. So if you see it like this in words, if P then Q, if the hypothesis then the conclusion. The symbolic part is this P arrow Q, and you read this, you say P implies Q. Means the exact same thing as if P then Q. P implies Q. Same-o, same-o. So let us look at this sample statement and then identify the hypothesis and the conclusion, and then let's rewrite it into if-then form. So this statement, all birds have feathers. Okay. What is my hypothesis and what is my conclusion? Sometimes it's easier to find the conclusion. Have feathers is like the result of what's happening. All birds is what the result is happening to. So all birds in this case is going to be our hypothesis, and feathers is our conclusion. Feathers is the result of these things being birds. So how would I write that in if-then form? If something is a bird, then it has feathers. And so, since we know that the only possible things that could be birds are animals, so we could say if an animal is a bird, then it has feathers. Let's look at one more. You are in Texas if you are in Houston. Now this one, the if here gives you a big clue. If you are in Houston, then you're in Texas. So you are in Houston would be our hypothesis. The conclusion is that if you're in Houston, we can conclude that you are in Texas. So if you are in Houston, then you are in Texas. Might be helpful to take a look at just a couple more examples. So here is a statement. All 30-degree angles are acute angles. So what is my hypothesis and what is my conclusion? Well, I'm concluding that these angles are acute, so the acute angles part has to be my conclusion, so it means that the 30-degree angles part is my hypothesis. Alright, so and how about if then? So do I just say if all 30-degree angles? That doesn't really sound like it makes sense. I can say if an angle measures 30 degrees, then that angle is an acute angle. There we go. Bada bing, bada boom. Let's look at one more. What? Algebra. Alright, so let's look at this. 2x plus 7 equals 1 because x equals negative 3. So what is the result and what is causing that to happen? So our hypothesis is what we're trying to say causes our conclusion. So this right here, this word, because, has cause in it. So the x equaling negative 3 is the cause of the 2x plus 7 equaling 1. So the cause, or the hypothesis here, would be our x equals -3, and the conclusion is that 2x plus 7 equals 1. So, in if-then format, if the hypothesis, so if x equals -3, then the conclusion, then 2x plus 7 equals 1. If P, then Q. So, in summary, we talked about conditional statements. We noted that they have a hypothesis, which causes a result, and a conclusion, which is the result and is sometimes easier to locate. If-then form, we practiced moving them from random form to if-then form, and we talked about our notation. P is our hypothesis, Q is our conclusion. This notation is P implies Q, and it means the same thing as if P then Q. You are an awesome person. Thank you for watching this video. And now, please go do this practice. If you do, all your wildest dreams will come true. And that's a guarantee, or your money back.